next example is solve x square into y square plus xy plus 1y dx plus x square y square minus x into y plus 1 x dy is equal to 0. And this is the is not exact differential equation. If we check whether dava m by dava y is equal to dava n by dava x, what is m is multiplied by this y, so x y cube plus x y square plus y, and this n is what, x cube y square minus x square y plus x. And if you find dava m by dava y and dava n by dava x, then these two are not equal. So we check first that dava m by dava y is not equal to dava n by dava x. Means the given differential equation is not exact differential equation, and we have to reduce this equation to exact differential equation. So the given differential equation is of the form f1xy. What is f1xy? Some function of xy. This is the function of xy, because when we say this bracket, this is the function of xy. If each term of this function is a power of x into y, so this is x into y square, this is x into y raised to 1, this is x into y raised to 0. So this is the function of xy, that is say f1x, f1xy, y dx, plus this is again the function of x into y. And so it is suppose f2xy, f2, it is not f2 x comma y, it is f2 xy, x into y. That is the function of x into y, some function of x into y. X dy is equal to 0. So this is the of this type. So this is the example in on the rule number 2. That is if the given differential equation m dx plus m dy has the form f1 x into y, y dx plus f2 x into y, x dy is equal to 0, then 1 by mx minus ny is integrating factor. But if mx minus ny is not equal to 0, and if it is equal to 0 in that type, then we have the answer x into y is equal to constant. We know that if mx minus ny is 0, then m by n is y by x, and from this m dx plus n dy, we have dy by dx is minus m by n, that is minus y by x. So separate the variables and integrating, we have the, that is if mx minus ny is 0, then we have a very easy answer. But if mx minus ny is not equal to 0, then 1 by mx minus ny is integrating factor of this type of differential equation. So the given differential equation is of this type, f1 x into y, y dx plus f2 x into y, x dy is equal to 0. That is the example is on the rule number 2. And so 1 by mx minus ny is the integrating factor. So first identify that this is the differential equation which is not exact, but it is of the type f1 x into y, y dx plus f2 x into y, this is the x into y function, x dy is equal to 0. And hence integrating factor is 1 by mx minus ny. So what is m? M is this and n is this. So what is mx minus ny? So multiply to m by x and multiply to n by y, we have this. And after simplification, we have x cube y cube plus x square y square plus xy minus x cube y cube plus x square y square minus xy. And so this become 2 times x square y square. Only we have the x square y square, and x square y square remaining terms get cancelled. There is 2 times x square y square, and it is not equal to 0. And so integrating factor is 1 by 2x square y square. So mx minus ny is not equal to 0, and therefore 1 by mx minus ny means 1 by 2x square y square is the integrating factor. So sometimes the MCQ type question is what? This is the given differential equation, and the question is determine which of the following is integrating factor. And so answers are given out of that. This is the answer, 1 by mx minus ny, that is 1 by 2x square y square, because this is of this form. So multiplying the given equation by this 1 by 2x square y square, it becomes an exact differential equation. So multiplying this equation, the given differential equation, by this 1 by 2x square y square. So we have 1 half x square y square, and multiply this by y. So x 1 by x square, this is 1 half, take common, and so x square y square by x square y square is 1, and this y means y, then x into y divided by x square y square. So it is 1 by x into y, and this 1 by x now multiplying this y, and now y is the term, y divided by x square into y square is y 1 divided by x square into y. Take 1/2 as this factor. Then 1/2 again 1 by 2 x square y square. So we have x minus 1 by y plus 1 by x y square dy is equal to 0. So after multiplying this 1 by 2 x square y square, we have this. Okay, and this is the exact differential equation which can be shown to be an exact. So no need to show that this is the exact differential equation. This is the exact differential equation. Now this is m and this is n, and if you find del by m by del by y and del by n by del by x, then both are same. And whose general solution is what? General solution is integration m dx, that is integration of this m dx plus terms in n independent of x. So that term is minus 1 by minus 1/2 minus 1/2 into 1 by y. So write that term. So terms in n independent of x is only one term, which is minus 1/2 into 1 by y. Okay, dy integration with respect to y. So we have this answer. So how we can give have has this answer? So 1/2 is constant, integration of y with respect to x is yx. So we have this term 1 by x log x, and 1 by y is now constant quantity, and the derivative of integration of 1 by x square is minus 1 by x, because derivative of 1 by x is minus 1 by x square. So integration of 1 by x square is minus 1 by x. So we have yx log x, yx plus log x plus minus not plus minus 1 by x into y, and this is minus 1/2 log y, and then we have this answer. Okay, so log x minus log y, take 1/2 shift the 1/2 to RHS, so is equal to constant of integration, suppose c1, and then 2c1 as c. So we have log x minus log y is log x by y. So we have this answer. So this is exact differential equation. Then write its general solution is what? Integration m dx plus terms in n independent of x is equal to constant c1 suppose, and then we have this answer. So next example, solve x square plus y square plus 2x dx plus 2y dy is equal to 0. The given differential equation is this. So compare with m dx plus n dy is equal to 0. So we have m as this, n as this, and if you find del by m by del by y is 2y, because the derivative with respect to y means x square derivative is 0, y square 2y, 2x 0. Del by n by del by x is 2y derivative is 0 with respect to x. And so del by m by del by y is not equal to del by n by del by x. And therefore the given equation is not exact. But we observe that del by m by del by y minus del by n by del by x divided by n. Divided by n. So what is del by m by del by y? It's 2y. Del by n by del by x is 0. Divided by 2y is 1. And is the function of x alone, or is constant. And so integrating factor is e raised to integration fx dx, that is integration of e raised to integration 1 dx, that is e raised to x is the integrating factor. So this is the example on the rule number 3. Okay, this is the example on rule number 3. Del by m by del by y minus del by n by del by x divided by n is function of x alone, or we say it is constant. Then what is the integrating factor? E raised to integration fx dx, or e raised to integration that c, that constant. Now value of, in this example, value of this quantity is 1. We have a constant value. If we have the constant value or function of x, then e raised to integration fx dx is the integrating factor. So e raised to 1 dx, that is e raised to x is the integrating factor. So multiplying equation 1 by this integrating factor, e raised to x, so we have e raised to x in the bracket this dx plus 2y e raised to x dy is equal to 0, and which is exact differential equation. This differential equation becomes exact differential equation. No need to check. If you have to check, then denote this is as m, this is as n, and find del by m by del by y and del by n by del by x. We have that both are same. So which is the exact differential equation, and its general solution is integration m dx plus terms in n independent of plus integration terms in n independent of x dy is equal to 0. And so what is m dx? This is e raised to x, x square plus y square plus 2x, don't write this bracket, plus 2x bracket complete dx plus 2x bracket complete dx plus terms in an independent of x. There is only one term 2y into e raised to x and is depend on m, depend on x, therefore 0. The terms in n independent of x are 0, so 0 dy is equal to constant. And then integration is u into v rule, suppose e raised to x as it is, and the rate of x square plus y square plus 2x dx is what? Integration, not that integration is what? Okay, so don't use u into v, we have to find integration. So we have the first factor e raised to x, x square, and then we have to obtain its integration by using part rule. Then x square as 1, e raised to x is as second, and then use part rule, or taken this e raised to x and this x square plus y square plus 2x as the first first function. And then what is its integration? Integration is by using part rule. So I applied two times part rule. We have this answer. So I will share you the simplification of this step to this step, the middle steps through your WhatsApp group. So how we can find its integration? By using part rule. So applied part rule twice, we have this answer, and this is the solution of this differential equation, general solution of this differential equation. So this is the example on the third rule. The next example, x y cube plus y dx plus 2 x square y square plus x plus y raised to 4 dy is equal to 0. So the given differential equation it is, compare with m dx plus n dy is equal to 0. We get m as this, n as this, and if you find derivative m by derivative y is this, the derivative with respect to y, x is constant, y cube derivative is 3y square plus 1, and derivative n by derivative x is this 2 as it is, and the derivative of 2x square as 2x, y square constant, plus derivative of x is 1, and derivative of y raised to 4 is 0. And then we observe that derivative m by derivative y is not equal to derivative n by derivative x. But the given differential equation is not exact. But we observe that derivative n by derivative x minus derivative m by derivative y divided by m. So what is derivative n by derivative x is this 2 in bracket 2x square plus 1 minus derivative m by derivative y is this divided by x y cube plus y as m, x y cube plus y. Then we have the simplification is 4xy square minus 3xy square become xy square, and plus 2 minus 1 become plus 1, divided by take y as common. So we have xy square plus 1 get cancelled, and so 1 by y, we have the answer 1 by y, and it's function of y only, and therefore integrating factor is e raised to integration F.Y dy, that is e raised to integration 1 by y dy, and integration of 1 by y is log y, and e and logarithmic function, exponential function and logarithmic functions are inverses of each other, and so e raised to log y is y, and so integrating factor is y. So this is the example on the rule number 4. Rule number 4, that is, if the given differential equation is not exact, but derivative n by derivative x minus derivative m by derivative y divided by m is function of y alone, that is pure function of y, or is constant, then integrating factor is e raised to integration F.Y dy, or e raised to integration c dy. Either this is equal to function of y alone or is constant quantity, then integrating factor is this. So this is the example on rule number 4, that is 1 by derivative n by derivative x minus derivative m by derivative y divided by m is function of y alone, and therefore integrating factor is e raised to integration F.Y dy, that is e raised to integration 1 by y dy, and that is e raised to log y, and so y integrating factor is y. So multiplying the equation 1 by y integrating factor, so we have x y raised to 4 plus y square dx plus 2 x square y cube plus xy plus y raised to 5 dy is equal to 0. So after multiplying that, we have this, and then this is now exact differential equation, and so which is exact differential equation. No need to check whether derivative m by derivative y is equal to derivative n by derivative x. This procedure indicate that this the differential after multiplying integrating factor, the given equation reduced to the exact differential equation. So this is the exact differential equation, and hence its solution is what? Integration m dx plus terms in n independent of x dy is equal to 0. And so this is x y raised to 4 plus y square is m dx plus the terms in n independent of x. There are three terms, x square y cube, this x into y, and this y raised to 5 and multiply by 2. So there are three terms, but out of that this term is depend on x, this term depend on x, the last term 2y raised to 5, this is free from x, and so write that term 2y raised to 5 dy is equal to constant, and then integration is with respect to x, means y raised to 4 is constant, and integration of x is x square by 2 or 1 half into x square y raised to 4 constant, and then y square is constant, and integration of constant is constant into variable, so y square into x plus 2 is constant, and the integration of y raised to 5 is y raised to 6 by 6. So 2 by 6 is 1 by 3. And so we have, this is the final answer. Okay. The next example, solve y square plus 2x square y dx plus 2x cube minus xy dy is equal to 0. So the given differential equation is this, can be written as, take y as common. This is wrong answer. So write, take split all these terms. So write y square dx, 2x square y dx, 2x cube dy minus x into y dy. Okay, and then this 2x square y dx and this 2x cube y dy, take 2x square as common. So what do we have? Y dx plus x dy in bracket. Okay, so these two terms, and the remaining terms are what? Y square dx minus x dy. So out of these two terms, take y as common. So we have y minus, right? Y minus x dy. Y dx, right? Y dx in bracket here is wrong. Y dx minus x dy. And this is the differential equation of this form. What is this? Is the differential equation of the form. So this is the differential equation of the form. Number 5, rule number 5. This is the example depend on rule number 5. So x raised to a, y raised to b, m y dx plus n x dy. So this bracket is of the type y dx plus n x dy. M and n are any constants, and x raised to c, y raised to d, y dx p y dx plus q x dy. So this is the example of this type. So this is the example of that type. So here is the correction right here in bracket, y dx minus x dy, x dy in the here bracket, then plus 2x cube y dx plus x dy is as it is. So this is the example of that type, and if the example is of that type, then integrating factor is x raised to alpha, y raised to beta. Now we have to find the alpha and beta. So this is the example on rule number 5. So now the example is of this form. So x raised to alpha, y raised to beta is the integrating factor where alpha and beta are to determine. So we have to find the alpha and beta. So we have a rough integrating factor. Roughly integrating factor is x raised to alpha, y raised to beta. Now we have to find the alpha and beta. So this is integrating factor. So multiplying equation 1, this given equation, by x raised to alpha, y raised to beta. So we have here x raised to alpha and y raised to beta into y square is y raised to beta plus 2, base same power, addition of power, then 2, and x raised to alpha into x square is x raised to alpha plus 2, then y raised to beta and into y raised to 1 is y raised to beta plus 1 dx, then 2x cube into x raised to alpha is x raised to alpha plus 2 y raised to beta, and then x into y into x raised to alpha, y raised to beta is x raised to alpha plus 1, y raised to beta plus 1, dy is equal to 0. And now this is the, now compare this equation with m dx plus n dy is equal to 0. So m is this and n is this, and then dava m by dava y is the derivative with respect to a y. So y raised to beta, y raised to x raised to alpha is constant, and the derivative of y raised to beta plus 2 is beta plus 2, y raised to beta plus 2 minus 1, that is beta plus 1, x raised to alpha as it is, that is x raised to m rule, plus 2 as it is, and then x raised to alpha plus 2 is constant quantity, and the derivative of y raised to beta plus 1 is beta plus 1 y raised to beta plus 1 minus 1. So this is the derivative of this quantity dava m by dava y. Then dava n by dava x is 2 alpha plus 3 raised x raised to alpha plus 3 minus 1, that is alpha plus 2 y raised to beta as it is constant. Then derivative of this y raised to beta plus 1 is constant quantity, x raised to alpha plus 1 derivative is alpha plus 1 x raised to alpha plus 1 minus 1. So we have this, and after multiplying, this is the integrating factor, x raised to alpha y raised to beta is the integrating factor. So after multiplying, we have this equation second, and this equation now is exact differential equation, and therefore dava m by dava y is equal to dava n by dava x. So we have these two are equal. So write dava m by dava y as this and dava n by dava x as this, and then compare the coefficient of x raised to alpha y raised to beta plus 1. So in the LHS it is beta plus 2. In RHS the coefficient of x raised to alpha y raised to beta plus 1 is minus alpha in bracket alpha plus 1. So beta plus 2 is equal to minus in bracket alpha plus 1, and so we have alpha plus beta is equal to minus 3 as the first equation, and this 2 beta in bracket beta plus 1 is equal to this 2 alpha plus 3, the coefficient of x raised to alpha plus 2 y raised to beta, and so alpha minus beta is minus 2. So we have to solve these two equations and find the values of alpha and beta. So adding these two equations, we have the alpha as minus 5 by 2, and substitute that alpha in equation number 1, we have beta is minus 1 half, and therefore substitute these values of alpha and beta in equation number 2, that is substitute alpha as minus 5 by 2 and beta is minus 1 half in the equation number 2. We have this equation, and this is the exact differential equation, and so its solution is what? Integration m dx plus terms in n independent of x dy is equal to 0 independent of x. So there is no term in independent of x, there are two terms, this is depend on x, this depend on x, so 0 dy, and this is m as it is dx, and so integration is what? Take y as constant, so integration is with respect to x means y is constant, y raised to 3 by 2 is constant, and integration of x raised to minus 5 by 2 is what? X raised to minus 5 by 2 plus 1 means x raised to minus 3 by 2 divided by minus 3 by 2 means into minus 2 by 3. So plus these two, and y raised to 1 half is again constant quantity, and integration of x raised to minus 1 half is x raised to minus 1 half plus 1 divided by minus 1 half plus 1 means x raised to half divided by half means into 2, and this 2 into 2 is become 4, and so this is the general solution of the given differential equation. So this is the example depend on the 5 rules. So after this, what we have, these are the 5 rules, and the below are this 10, then 11, 12, 13 and 14. Okay, so these 5 examples are the examples of depends on the rule number 1, 2, 3, 4 and 5. So continuously we have solved that these 5 examples on the 5 rules. So the remaining examples, the next example is this, solve this example. Okay, solve this again. This is either this, now from this example the remaining examples are of the mixed type, that is this example is the exact differential equation, that is either the given differential equation is exact or the given equation is not exact but reducible to the exact by using the method either inspection method or by using one of the rule out of the 5 rules. So we will see the remaining examples in the next lecture.